Now, for the shifting, logical shifting, this is actually logical right shift. All right, so let's see the result. So, see what exactly has happened, that A is 8 and B has become what? 4. How come? Basically, what happened, that A in binary is this: 1, 2, 4, 8, 16, 32, 64, 128. When this shift goes right, B will become, so this bit will be dropped and 10 will enter from the left side. So when this bit will be dropped, it means that this will come one side towards the right, one step towards the right, one place towards the right. So this was 8, what it has become? 4. This is apparent. If we run this program, we can see that 8 has become 4. So if you could look at it in binary form, you can see that. Okay. So what is exactly the effect when we basically shift right logically? The number becomes half. Now let's make this be A shifts one time left. So this one is logical left shift. What is it? Logical left shift. So B will become what? So this time A has gone left one place. So it was 8, this has now become 16. Alright, so let's see what is the result. So A was 8, when it was shifted left one place, it has become what? 16. Let's see what is the question. Then outcome will be 1. What outcome will be 1 with it? I don't get it. Please elaborate. Alisa, outcome will be 1 what? If 8, if A is 8 and we shift it towards left, it will become 16. If we shift it towards right, it will become 8. 4. Alright. This was an idea for left and right shifting. This is shifting. Now, let's do ending. End. What is ending? Bitwise AND operation of the contents of accumulator with the operand. Let's first discuss how ending actually works. bitwise in, or even we call it ender. Let's say we have got A, the value of A is, let's say, 18. 18 is 1, 2, 4, 8, 16, 32, 64, 128. This is in binary. Let's say we have got B. B is, let's say, 20. 1, 2, 4, 8, 16, 32, 64, 120. Now we know what is AND operation. What AND does, if there is any zero, the result is zero. Otherwise, if there are all ones, then it becomes what? 1. And first we will carry this operation on one bit on the least significant side, on this side. 0 and 0, 0. 1 and 0, 0. 0 and 1, 0. 0 and 0, 0. 1 and 1, 1. 0 and 0, 0. 0 and 0, 0. 0 and 0, 0. So let's say it is C. C would become what? 16. If we add 18 and 20, it will become 16. Alright? So let's see how actually it happens in Visual Basic Language. Let's say A is 18, B is 20. Let's create another variable C. In C as integer as well. And C is equal to A and B. See, C is equal to A and B. So let's see what is the answer of C then. Let's execute this program. As I told you that if A is 18, B is 20, then the result or C will be 16, because we end bitwise. Bitwise means doing from the right side towards the left, bit by bit by bit by bit. So the answer is 16, that you can observe over here easily. That if A is 18, B is 20, and C is equal to A and B, then it will become 16. That is the result. Okay. Now let's say if it is ORing, same 18 and 20, you do it and let me know what is the result of ORing A and B when A is 18 and B is 20. What is the result? C, both in binary and in denary. So with ORing, the result becomes 22. 18, A is 18, B is 20, C is 22. Alright, so now do exclusive for Zoring. So let's say if we are doing same, A is 18, B is 20, what is the result of exclusive for? So exclusive for whenever the values are same, the result is 0. Whenever the values are different, result is 1. So C will become what? 6. 1, 2 and 4. Let's see in Visual Basic. Yes, it is now. So exclusive for. Let's see the result. See, it is 6. So now we know that how logical shifting works, how computer actually deals with it, and then we have seen that how the language is actually dealing with it. Exactly, the language is dealing with it the way we expected it through our theory book. All right. So in monitoring and control, each bit in a register or memory location can be used as a flag and would need to be tested, set and cleared separately. Okay. Now it means that with assembly language help, we can manipulate any bit in the computer's memory or device register if it is allowed. So for example, a control system with 8 different sensors would need to record when the data from each sensor had been processed. This could be shown using 8 different bits in the same memory location. So let's say this is our register. We have got 8 bits in it. It's in any device. Every single bit is representing a sensor. So it's a register. Okay. Now we have got different sensors related to different bits of this register. So whenever a sensor is sending data or we want to control anything, we can make these bits zeros and ones individual. So if we use AND, AND is used to check if the bit has been set. AND is used to check if the bit has been set. Alright? AND is used to check if the bit has been set. Whereas OR is used to set the bit. Is used to set the bit. So let's say we check a bit, if it is 1, then we do something. If we like to set a bit, setting a bit means putting 1 into it. Setting a bit means putting 1 into it. And clearing. Clearing requires you to use OR. So OR is used to clear a bit that has been set. Alright? So OR has been used to clear a bit that has been set. Okay, so when do we need OR? When we like to set the bit. When do we need AND? When we like to check if the bit is set. When do we need exclusive OR? When we like to change, sorry, um, clear a bit. Now, let's say I have got this register set as 0, 1, 0, 0, 1, 0, 0, 0. I like to change this third bit. I like to change this third bit to 1. So what I will use OR. How I will use OR, that is actually the matter of concern. So I have to make OR. So if I want to set a bit, I will put 1 there and leave everything else 0. So this making of this new value is actually the whole combination of this new value which is in red is called mask. What do we call it? Mask. And we perform OR operation over this mask. So in the result, what do we get? 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, and 0, 0, 0. If you could see the difference between this and this registered values, you could see the bit which is marked is now set to 1. What if I like to clear this one? What if I like to clear this one, and I would like to keep this? What I will do, I will create a new mask that will be used with exclusive OR, because it says that exclusive OR is used to clear a bit. Exclusive OR is used to clear a bit. Okay, so let's see, we are going to create a mask. We want to clear this particular bit. Clear means we want to make it 0. So we will put 1 over here and 0 at all different places. So this is a new mask that I have created to make this particular bit clear. Means to put 0 in it. Now see what is the result of these two exclusive for 0, 0, 0, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 0, 1, 0. So if you see the difference between these two, only the bit which was marked here is now 0. Rest of the bits are the same as they were. So exclusive for is used to clear a bit. Let's see what someone has asked. Sir, what is the purpose of the mask? The purpose of the mask is to create a combination that can be used to clear few bits, to set few bits, or to uh, check few bits. So mask is not just for one bit. We may use this mask to set several bits together, to clear several bits together, and to check several bits together. Alright, that is how it works. So you would have to create your own mask. So I wanted to set this bit, so I created this mask. So whatever the bit that I wanted to set as 1, I put 1 and rest are now zeros. So if I would have put 1 over here and over here, so these three, 1, 2 and 3 will have become what? Ones. मतलब set होगा. Similarly, if I want to clear and I want to clear, let's say 1, 2 and 3, so I will be putting 1 here and 1 here. So whatever the values, those are ones already will become what? 0. Alright. So let's say this particular mask, is it possible to change multiple bits with the same mask? Yes. वही तो मैं आपको बता रहा था जोएल कि जो भी आपको सेट करना है वहां पे आप वंस लगा के और कर दें वो सेट हो जाएंगे. अच्छा अभी हम उस पर आते हैं. अभी आप थोड़ा सा समझने की कोशिश करें with respect to the assembly. So let's say we have got this data in the computer's memory. Let's say I've got this data at address 92. I have this saved as 0, 1, 0, 0, 1, 0, 0, 0. So this is at address 92. In computer's memory, immediate access store. I have to set this bit as 1 and I would like it to be saved at address 93. What program will I write in assembly language? First I would have to load. So LDB 92. So this 92 will be loaded to what? Accumulator. Now I will apply my mask to the accumulator. So I'll be like exclusive OR. This is now an opcode, a command opcode. I want to set, oh sorry, I want to set, yes. So not exclusive OR, rather I'll be using OR only. Okay, so I will be creating my own mask. So mask is in binary form, so I'll be using B. If you do remember, I told you that if the value that you are going to give, that should be B. And now that value is a value as constant, it is not an address. So I'll be using hash B. Now what is your mask? Your mask is alright. So I wanted to change this one. So 001 As this was in binary form, we have to put B, and it is value itself. It is not in any computer's area. Sir, that binary is producing a number 82, not 92. Today, this is not the value. This is the memory address. This is content. Alright, so we have loaded this data at the address 92 in computer's memory, and then we applied the mask to it. Now we have got what the changed value with this third bit set as 1, and I would like to save this value back to address 93. So I'll be like store at 93. So what do I get at 93? 0, 0, 1, 1, 0, 0, 1, 0. This is a changed value. This is what you have to learn, that if some data is present at some memory's location, we want to manipulate that data in a bit or in several bits. We would have to load that data from the memory to accumulator. We will apply mask to it and proper exclusive or and or opcode to it, and then we will store the data back to the memory. Alright, that is how it works. So this is it for the lecture today. Let me revise what we have done today. I actually tried explaining that how bitwise operations with ending, exclusive for, and ORing works, and then I did try explaining them by writing a computer program in Visual Basic for it. Basically, you are not supposed to create the program in Visual Basic, but you are supposed to do this using assembly language. Then we use few of the examples, and then I told you that we create a mask. So until now we created the mask for one and only one bit as of yet, but this mask can be created for several bits. Now we will learn how to actually change the data in assembly language. So data is somewhere in the memory. We have to fetch that data, load that data in accumulator, and then we do the operation with it, and afterwards we store the data back to the memory. This was actually the gist of what we have learned today in this lecture, and in next lecture we will be writing bigger programs which will be dealing with complex mass, past paper question solutions and all. If there is any question, please do ask.